Good day, I'm Marvin Enriquez, your subject teacher for probability and statistics. With this video lesson, we're going to discuss the topic null and alternative hypothesis and test statistics. Our lesson objectives: at the end of this lesson, you are expected to formulate the, the appropriate null and alternative hypothesis on a population mean and identifies the appropriate form of the test statistic when the population variance is assumed to be known, the population variance is assumed to be unknown, and the central limit theorem is to be used. In this lesson, you will continue to learn about hypothesis testing. So hypothesis testing is very important in dealing with your research because we really need to assess and check if your assumptions or your hypotheses are acceptable or not. You will learn how to formulate your null and alternative hypothesis. So your null will show that there is no specific uh, or there is no significant difference between your two variables involved, and your alternative hypothesis will show or shows that there is there is an existing differences between your two variables involved. So with this lesson, you will learn how to formulate the null and alternative hypothesis regarding the population mean. So there is an involvement of your population mean, and we need to identify the appropriate form of the test statistics when the population variance is assumed to be known, assumed to be unknown, and once we apply your central limit theorem in your research. In hypothesis testing, there is a claim being made about the population parameter. So the claim could be in the null hypothesis HO. So we simply use HO to represent your null hypothesis, and we simply use your HA to represent your alternative hypothesis. It has remembered the statement of equality for a null hypothesis, such as, so most of the time we only use equal sign because there is a keyword here that your null hypothesis always represent your equality. But there are times that we need to use your less than or equal to or greater than or equal to. But again, most of the time, we only use equal sign for us to represent your null hypothesis. So while the alternative hypothesis has a statement of inequality, as long that your statement or your assumption shows that there is an existing differences now between your two variables involved, so we simply use your greater than, your less than, or not equal to as a symbol that will represent your alternative hypothesis. So each hypothesis, is the complement of the other, and only one of them is true. So we cannot accept both your null and alternative hypothesis at the same time. So if we decided or based on the test statistics, based on the values, and we prove that your null is acceptable, then we're going to reject your alternative hypothesis. And if your null should be rejected, then we should reject your null and we accept your alternative. But we cannot accept your null and alternative hypothesis at the same time. That's why only one of them is true. And we need to choose based on the values that we can get from your test statistics as our basis in choosing between your null and alternative hypothesis. Is it your null or your alternative hypothesis? So we really need to choose what is a true statement between these two hypotheses. So take note. So there are common phrases of hypothesis testing. So we simply use this symbol to represent greater than, above, higher than, longer than, bigger than, is increase. So if you see these phrases no in the given problem, no, when you say that we're going to use this symbol greater than, the symbol greater than to represent your alternative hypothesis. While when we're using your less than sign, no, it represents your less than, below, lower than, shorter than, smaller than, decrease or reduce from. Again, from the statement, if these phrases are being mentioned in the problem, then we simply use your less than or the sign that will represent your less than. This will be your sign. Now, dealing with your null hypothesis, a while ago I said that we we always use this symbol to represent your null hypothesis. So it represents equal to, is the same as, has not changed from, is the same as. So we use this equal sign to represent your null hypothesis because your null will represent uh, equality. Meaning, say if there are two variables involved, there is no difference. Meaning, say that your x sub 1 is equal to your x sub 2. If your x sub 1 is your first variable and your x sub 2 is your second variable, once you're dealing with your null hypothesis, meaning to say that there is no significant difference between those variables, that's why we can conclude that your x sub 1 is equal to your x sub 2. For your fourth symbol here, not equal to, we use this again to represent your alternative hypothesis. It will represent not equal to, different from, has changed from, and is not the same as long that your phrase no does not show a superior or inferior to, then we simply use this not equal to because we don't know if the value or your given value is greater than or less than with your parameter, or it will fall in your or in between your lower and your upper limit. If the claims includes equality, then the claims is in the null hypothesis. Yes, it is no. That's why we simply use equal sign to represent your null hypothesis. We always assume that your population mean will fall on your parameter. That is your null hypothesis. However, if the claim does not include equality, then the claim is the alternative hypothesis. As long that your statement does not show um, equality no, between your variables involved, that will be your alternative hypothesis. In formulating the null and alternative hypothesis, the null hypothesis should be written first, followed by alternative hypothesis. In dealing with your hypothesis, no, in making your hypothesis or in formulating your null and alternative, we should first formulate your null hypothesis. We always start in assuming that your population mean is equal to your parameter or it will fall within your parameter. Then we can move forward in dealing with or in formulating your alternative hypothesis. Using the pretest give above as our example in the terms of parameter, so we simply use this mu and your your mu for population mean, and this row for your population proportion. Again, mu for your population mean and your row for your population proportion. So let's deal with this example for us to visualize more what is your null and your alternative hypothesis. First example, your statement is that the mean number of years Americans work before retiring is. So there is no keyword here, less than, greater than, or not equal to, increase from, change from. So therefore, we assume that your null hypothesis is that your population mean is equal to 34. Because your statement shows no, or it represents that the mean of the number of years of Americans who work before retiring is 34. Now, what will be your alternative? From our previous video lesson, we we said that your alternative hypothesis is totally opposite of your null hypothesis. Now, there is no keyword here less than or greater than in your statement. So therefore, we don't know if your population mean is less than or equal, I mean less than or greater than to 34. So we simply use your not equal to because we don't know if your population mean mu is less than or greater than 34. That's why dealing with your alternative hypothesis, no, it will represent that there is no equality between your population mean and your parameter. That's why we simply use not equal to because we don't know if your population will fall before and or after 34. For number 2, at most 60% of Americans vote in presidential election. So there is a word at most here. 60% of Americans vote in presidential elections. Now, in this statement, we are dealing with your population proportion. Now, in this case, our solution HO now, or your null hypothesis, is that your population proportion is less than or equal to 0.60. So we just simply convert this 60% to decimal. So we divide it by 100 to make it 0.60. Then there is a keyword here at most. So we simply use this to your null hypothesis. So your population proportion now, rho, is less than or equal to 0.60. So meaning to say that the maximum value that we can meet for the population proportion is 0.60. It can be equal to 0.60 and less than 60, 0.60 I mean, but not more than or greater than 0.60. Because there is a keyword here, at most, the maximum amount or the maximum value that we can meet for the population proportion is 60% or 0.60. Now, for your alternative hypothesis, your rho is greater than 0.60. If we assume in your null hypothesis that your population proportion is less than or equal to 0.60, then your alternative hypothesis is totally opposite of that statement. That's why your rho here is greater than 0.60. So all values of your population proportion should be greater than 0.60 once you are dealing with your alternative hypothesis. For your number 3, statement number 3, the mean starting salary for San Jose State University graduates is at least $100,000 per year. So meaning say we simply use this keyword here is at least. So we simply use this at least no in your null hypothesis. Now your null hypothesis, your mu, is greater than or equal to $100,000. Meaning to say, dealing with your null hypothesis, the minimum value no that we can get from this population mean is $100,000. It can be equal to 100,000 and greater than, but not less than 100,000 because there's a keyword here at least 100,000. Now, since a while ago we said that your HA is totally opposite of your null hypothesis, so we simply assume that your population mean now is less than 100,000. That's why we use this less than because your alternative hypothesis here is totally opposite of your null hypothesis. If we assume that your population mean is greater than or equal to 100,000, then our alternative hypothesis is your population mean is less than 100,000. That is the opposite of your null hypothesis. For number 4 statement, 29% of high school seniors get drunk each month. So still, we're dealing with your population proportion rho, then your HO is equal to 0.29. Because we assume here in this statement that your population proportion rho is equal to 0.29 or 29%. Now, there is no keyword in your statement. There is no less than, greater than, at least, or greater than, at most. Then we simply use the symbol not equal to because we really don't know if your population proportion will fall before 0.29 or after 0.29 because there is no keywords on your uh, statement number 4. For us to oppose this null hypothesis and your alternative hypothesis now, your population proportion is not equal to 0.29. For your fifth statement, fewer than 5% of adults ride the bus to work in Los Angeles. Now, for your null, we assume that your population proportion is 0.05. So we simply convert, no? So we simply convert this 5% to decimal and we divide by 100. Then your alternative hypothesis, we simply use this fewer than, no? 5%. That's why we assume that your alternative hypothesis now and your population proportion is less than 0.05. Here we apply your fewer than 0.0 in 0.05 for your alternative hypothesis. So consider the following situations. A manufacturer of IT gadgets recently announced they had developed a new battery for a tablet and claimed that it has an average life of at least 24 hours. Would you buy this battery? So the null hypothesis can be stated as your HO, the average life of the newly developed battery of a tablet is at least 24 hours. So here, if we convert this statement to symbol, so that will be equal to your population mean mu uh, greater than or equal to 24. So we apply your at least 24 hours. But there are some books that we use only your is not equal to, because your null hypothesis will show or will represent an equality between your two variables involved. So while the alternative hypothesis is, so the average life of a newly developed battery for a tablet is less than 24 hours. Because we assume that your population mean is greater than or equal to 24 in your null, then since we said that a while ago, no, that your alternative hypothesis is totally opposite of your null, HO, then your population mean in your alternative hypothesis is less than 24. So that will be our assumption for your alternative hypothesis. Now, a type 1 error is committed when you did not buy the battery, and a possible consequence is you lost the opportunity to have a battery that could last for at least 24 hours. On the other hand, your type 2 error is committed when you did not buy the battery and found out later that the battery's life was less than 24 hours. So a possible consequence of this type 2 error is that you wasted your money in buying the battery. Because at the end, no, we found out that the battery's life was less than 24 hours. Then the possible consequence for that is you wasted your money in buying the battery. So for number 2, consider a manufacturing process that is known to produce bulbs that have life lengths with a standard deviation of 75 days. A potential customer will purchase bulbs from the company that manufactures the valves if she is convinced that the average life of the valve is 1,550 days. So our HO, based on your statement, so we always formulate your null and alternative hypothesis based on the given statement. So from that, we can formulate your null and alternative hypothesis. So for your null, the average life of bulbs is at least 1,550 days. So if we convert this one to symbol, that will be your mu greater than or equal to 1,150, because there is a keyword here, at least, mean to say the minimum value that we can get from this life of a bulb is 1,150. That's our assumption. It can be greater than or equal to 1,550. For your alternative hypothesis, because since your alternative is totally opposite of your null, then we assume here that the average life of bulb is less than 1,550. Therefore, if we convert this into symbol, your new population mean is less than 1,550. So a type 1 error is committed when we declare that the average life is less than 1,550 days, when in fact the average life is 1,500 days or more. So once we reject your true null hypothesis, so that will be your type 1 error. So on the other hand, type 2 error is committed when we declare that the average is at least 1,550 days, when in fact it is less than 1,500 550 days. So that's how we commit your type 1 and type 2 error based on the given statement. And right after formulating your null and alternative, then we can see or we can predict what will be uh, our type 1 error, or how can we commit on this type 1 and type 2 errors. So let's deal now with your test statistics. So we are done formulating your hypothesis. So we know how to formulate your null and alternative based on the given situations or statements. No? Let's now proceed in identifying the appropriate form of the test statistic you will learn when to use the C-test and T-test in conducting a hypothesis test. So a C-test is a statistical test used to determine whether two population means. So please do take note of this. We simply use your C-test to determine whether your two population means are different when the variance are known and the sample size is large. When you say that your sample size is 30 or greater than 30. So the test statistic is assumed to have normal distribution, and the parameters such as standard deviation should be known in order for an accurate C-test to perform. So here, there's being mentioned here that to have a normal distribution, no, we simply apply your central limit theorem once your sample size is large, because your central limit theorem states that even your n or your sample size become larger and larger, then your distribution is still normal, or your distribution approaches uh, to a normal uh, normally. No, your C tests are closely seven related to t-tests, but t-tests are best performed when an experiment has a small size, according by central limit theorem. So most of the time, we simply use your c-test if there is a large sample size, and if there is a small sample size, we simply use your t-test. And it will be t-tests are best performed, no, for this small sample size, according by central limit theorem. So when to use c-test? So a c-test is used when the variables follow a normal distribution. So dealing with a large size, no, we simply use c-test and we apply your CLT, because the concept of CLT will provide you that even your n becomes larger and larger, still your distribution becomes normal. So, and the population variance is known. So your population variance is that your sigma is square. So we simply use this symbol to represent your population variance. It is also applicable when the population variance is not known. No? So we simply use this C-test even if your population variance is not known, but the sample size is greater than or equal to 30. No. So there are two things that we need to consider. So we use C-test if uh, your variable follows a normal distribution and the population variance is known. The second thing is that even if your population variance is unknown, but your sample size is greater than or equal to 30, then we can still apply your C-test with the concept of your CLT, or the central limit theorem. So the third one, so the C value can be solved using the formula that your C is equal to your sample mean minus your population mean all over your population standard deviation sigma over your square root of your sample size n, where for our guide that your C is your C value, your X bar is your sample mean, your mu is your hypothesis population mean, because we simply or we often use this mu for us to represent your null and alternative hypothesis. That's why we consider this mu as your hypothesized population mean, and to be subjected for verification in your test statistic. Your sigma, your population standard deviation. N is still your sample size. Note, when the population standard deviation is not known, use the sample standard deviation. So if the population standard deviation is not known, sigma, then we can use S, no, as a replacement of this population standard deviation. Again, if your population standard deviation sigma is not known, we simply use your sample standard deviation as a replacement for the value of your population standard deviation. So here we can use S, no, as a value for your population standard deviation if this sigma is not known. So for example, in your C-test, the school doctor said that the mean height of grade 12 boys is greater than 147 cm. The claim was suspected to be inaccurate. A random sample of 50 grade 12 boys was tested and found that the average height is 150 cm with a standard deviation of 15 cm. The appropriate statistical test is C-test that uses the C formula here, that your C is equal to your X bar, that will be your sample mean, minus your mu, your population mean, all over your sigma, your population standard deviation, all over your square root of n, which is your sample size. Since the sample size is 50 and the population standard deviation is unknown, then we simply, so these two indicators here, your sample size is large and your population standard deviation is unknown, the sample standard deviation can replace the population standard deviation. So we simply here, no, as a replacement of your sigma, we simply use S for your sample standard deviation. So as a replacement for your population standard deviation, we simply use S, your sample standard deviation, for us to go or for us to compute the value of your C. Now, since your N or your sample size is large or is 50, so that will be a large sample, then this unknown, this unknown standard deviation is unknown, then we simply apply your CLT for us to get that, or we can say that your even your N becomes larger and larger, still your distribution is normal. So when to use t-test? So the t-test is used when the population variance is unknown and the sample size is small. Mean to say, if your sample size is 29 down, mean to say 29 to 1, that will be considered as a small sample, which is less than 30. So the population must be normally distributed and nearly normally distributed. So here we don't need to apply your CLT because your N is less than 30 or your N is a small sample size. Then your population must be normally distributed or nearly normally distributed. If that not totally normally distributed, it must be nearly normally distributed. So the t value can be solved using the formula t. Your x bar is your sample mean, minus your mu is your hypothesized population mean, then your S is your sample standard deviation, and N is your sample size. Here in your C-test, we simply use your sample's standard deviation S, no? if the population standard deviation sigma is unknown. So we simply replace this sigma choosing the value per S if the sigma or the population standard deviation is unknown. So for example, for this t-test, so the president of a company claims that the scent of a car air freshener, no, lasts more than 30 days. So he claims that the scent of this car air freshener lasts more than 30 days. So the manager of the company suspected the claim and took a random sample of 20 and conducted a study. It was found that the mean time the air freshener lasts was only 20 days with a standard deviation of 2 days. Assume that the distribution is normally distributed. So here the solution. So the sample size is less than 30. So we simply use t-test. So first thing to think no is to use your t-test for your test statistics when your sample size is less than 30 because your sample size is only 20. So we only subject no random sample of 20 and the population standard deviation is unknown. So once your sample size is a small sample which is less than 30 and your population standard deviation is unknown, the statistical test to be used is t-test, which uses the formula t. So here, we use your sample standard deviation as, no, as a value in your denominator. Or, I mean, the value in the numerator in your denominator, which is S. This is sigma in your c-test. Now, with your value or x bar, your sample mean x bar minus your population mean mu all over your s, which is your sample standard deviation, over square root of your n, which is your sample size. So for your activity in this video lesson, first you need to explain why the null hypothesis is called null. So there is a reason why we call null. For number two, state the null hypothesis and alternative hypothesis in words and in symbols, I mean. So there's a given scenario here and you're asked to state the null hypothesis and alternative hypothesis in words and in symbols. So that will be your activity for this video lesson. So thanks for watching. If you want to like, comment, share, and subscribe, so please do so. I'm Marvin Enriquez, your subject teacher for probability and statistics.